Welcome to the lesson on annuities. In this lesson, we will learn to calculate the value of an annuity. Now first, let us define an annuity. An annuity is a sequence of equal payments made at equal periods of time. The time between payments is called the payment period, and the time from the beginning of the first payment period to the end of the last period is called the term of annuity. Now, annuities can be used to accumulate funds. For example, when you make regular deposits into a savings account, or when you use to pay out funds, like when you receive regular payments from a pension plan after you retire. Now, the formula that you see here is called the savings annuity formula. P sub n here is the balance in the account after n years, or this is the future value or the accumulated value after n years. The D here is the regular deposit, the amount that you deposit each year, each month, each quarter, etc. Now R here is the rate of interest, and this is usually expressed in decimal form. Now the K here is the number of compounding periods in 1 year. For instance, if you make deposits or payment every year, the yearly compounding is 1. That means K is equal to 1. Now if you make deposits every month, then use the monthly compounding, K is equal to 12. And if you make deposits or payment every quarter, K is equal to 4. If you make it semi-annually, K is equal to 2. And if you make it daily, K is equal to 365 and so on. Now, annuities assume that you put money in the account on a regular schedule. The schedule could either be monthly, yearly, quarterly, semi-annually, etc. And let it sit there earning interest. Let's take a look at this example. A traditional individual retirement account, or called IRA, is a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw it. Now, suppose you deposit $1,000 each month into an IRA savings account earning 5% interest. How much will you have in the account after 20 years? So to solve this, we will use the formula P sub n. This is the accumulated amount after n years, is equal to D times quantity 1 plus R, that is the rate, and over K, that's the number of compounding periods, raised to N, the number of years, times K, K is the number of compounding periods, minus 1, divided by R over K. Now, so to compute this, let us evaluate, or let us identify the values for each of the variables here. Now this $1,000 here is the amount of payment each month, or that's the amount of deposit each month. So this is your D. And the 5% here, that's the rate of interest, so that would be your R. Now R is usually, or R should be expressed in decimal, so you convert 5% to decimal. 5% is just 0.05 in decimal. Now 20 years here is your capital N, so that's the number of years. Then you just have to plug it in to the formula. We have D equal to 1,000 times 1 plus R. R is 0.05 divided by K. Now, this is you made a deposit each month. So each month. So therefore, the compounding periods, K is equal to 12. So divided by 12. Raised to the number of years, 20, times the compounding period, which is 12, minus 1. And then all over rate 0.05 divided by 12. Then you plug it into your calculator. Now let me demonstrate how you would input this to your calculator. We're going to use ClassCalc Scientific Calculator, as this will be the scientific calculator that will be available to you during your test. So to begin, we will have the fraction. So let's start with the fraction. So you just have to write first your D is 1,000, and then divided by, so that would be your fraction, so that everything will be on top. So times, and then you put a parenthesis, 1 plus R over K, so another fraction. We have your R is 0.05 divided by, that's how you would make a fraction, all over K. K is the number of compounding periods, which is 12. Then you put it in here so that you can enclose the parenthesis, and then you raise it. This will be for the exponent. Raise this to 20 times 12. And then bring this one down, minus 1. That will be your numerator actually, and the whole thing has to be multiplied by 1. So there should be another parenthesis here. Yes. So this is how your numerator would look like according to your formula. And then divided by, the denominator is R, so 0.05 R divided by 12. That gives us 411,033.67. So now, as shown in our calculation, this is equal to $411,033.67. So this is the amount in the account after 20 years. Next example. To save for retirement, you decide to deposit $10,000 into an IRA at the end of each year for the next 30 years. If this savings annuity has an interest rate of 5% per year compounded annually, then how much interest will you earn over the course of the 30 years? To solve this, we will use the annuity savings formula given by P sub n. P sub n equal to D times 1 plus R over K raised to n, the number of years, times K compounding period minus 1, all over R over K. Now, R here is equal to, or the rate of interest is 5%, and R should be written in decimal form. So 5% is 0.05. Now, D is the amount of payment, in this case yearly, that is 10,000. So this is your D. And then the 30 years here is the number of years. N is equal to 30. Now we plug it into the formula. 10,000 is your amount of payment each year. Rate of interest 0.05 divided by 1. K is equal to 1 because this is compounded annually. So K is equal to 1. And then raised to 30, that's the number of years, times 1, compounding, that's the number of compounding periods, minus 1. Then quantity divided by all over 0.05 over 1. And then plugging in that into your calculator, you should get 664,388.48. So in here, we are asked to find the amount of interest you earn over the course of 30 years. So to do that, we will first compute the number of or the amount that you paid over 30 years. So that is just 10,000 times 30. That is the amount, the total amount you deposited for the last 30 years. And that should be equal to 300,000. And then from this amount here, the 300,000, will be subtracted from 664,388.48 because this is the accumulated amount in the account after 30 years. And this is the total amount you deposited. So get the difference between these two. The answer is $364,388.48. Now let us consider the case when we need to calculate the payment needed to achieve a determined future value. In this case, instead of the accumulated amount P sub n being the unknown, we have the D here, the regular deposit amount, each year, each month, each quarter, etc. is the unknown. Now, usually this P sub n here is some type of a goal like a retirement amount, and it is the amount desired to be in the account after a certain number of years. And the D is the amount being deposited in the account on a regular basis. So to illustrate how to solve this type of problem, let us consider the following question. You want to have $500,000 in your account when you retire in 30 years. Your retirement account earns 5% yearly interest. How much do you need to deposit each month to meet your retirement goal? So to solve this, we will use the same formula, P sub n equal to D times 1 plus R over K raised to N K minus 1 divided by R over K. And then let's identify the value of each of the variables here. This 500,000 here is the goal, so that should be the accumulated amount, so that should be your P sub n. And then the 30 years here is the number of years, so that is your capital N. And 5% here is the rate of interest, so R is equal to 0.05. And then we want to know how much you need to deposit each month to meet your retirement. So that means each month you make a deposit each month, so the number of compounding periods is equal to 12 because there are 12 months in 1 year. Then to solve this, all you need to do is plug into the formula the value of each of those variables. So your P sub n is 500,000 equal to D is the unknown times 1 plus R over K. Oops. So your R is 0.05 over K, which is 12, raised to 30, that's the number of years, times 12, that's the number of compounding periods, minus 1, divided by 0.05 over 12. And then you simplify this, plug this into your calculator. Now to plug this into your calculator, there's a parenthesis here. All you need to do is consider this amount here, or this fraction here. So only this fraction here. You don't include the D because that is what we need. So we want to just evaluate this part here. Now let's go ahead and plug this into your calculator. This would be our numerator. So we have, it's the inside, so 1 plus 0.05 divided by 12, and then raised to, so it should go out there, raised to 30 times 12 minus 1. That's the numerator. Divided by 0.05 divided by 12. That is 832, and then you have to write as many decimal places as you can so that you get to the close value, or so we just write this whole amount here. Now, based on our calculations, we have D times 832.25. Let's just use 4 decimal places, 86. And then to compute this, we have the equation 500,000 is equal to D times 832.2586. Now to solve for D, all you need to do is divide both sides by 832.2586. So 832.2586. And then this is equal to, so when you plug this in, D is just equal to $600.78. So $600.78 is the monthly payment to meet your retirement goal of $500,000 in the account after 30 years when you retire. Another example, you want to have $2 million in your account when you retire in 30 years. Your retirement account earns 5% yearly interest. How much do you need to deposit each month to meet your retirement goal? So your retirement goal is $2 million. So that would be your P sub N. This is the accumulated funds after 30 years. 30 years or 30 is your N. And the rate of interest is 5%. So R is equal to 0.05 in decimal. You want to know how much you need to deposit each month. So that means K is equal to 12. The number of compounding periods is 12. And to solve this, we will use the same formula, P sub N equal to D times 1 plus R over K raised to capital NK minus 1 divided by R over K. And then we plug in the amounts that we have. The accumulated, or P sub N is the accumulated amount, which is 2 million. And then and D is the monthly payment. So that's the unknown, times 1 plus 0.05, that's the rate, divided by 12, that's the number of compounding periods. N is 30, K is 12, minus 1, divided by 0.05 over 12. And then you plug this into your calculator. We have D times 832.2586. And then you divide, to solve for D, you just have to divide 2 million by 832.2586. And that will give you 2,403.099. So this is the amount that you need to deposit every month, 2,403.099. Or you could round this off to the nearest 2 decimal places, and that will just give you 2,403.1 or $0.10.